Hi, I'm Jie Zhao. My final project topic is Boston Food Safety Conversation AI Data Analyst. Some quick background. So Boston health sector deduct some health inspection in food establishment restaurant every year. And they also have a follow-up for those high-risk establishment to make sure they continue fix or update the inspection results. And this inspection results generate a large amount of public data, including business information, violation description, inspect results, dates, location, etc. And the restaurant owner, public health official, city analyst, and public consumer like you and me had a challenge to identify repeated violations, understanding violation meaning, analyze inspection trend, or determine which establishment has higher food safety risks. And a few common challenge like the inspection comments contain some unstructured text. And the technical violation codes and inspection terminology are difficult for non-technical user to integrate. And some similar food safety issue may be described differently across inspector and reports. The traditional keyword search may miss semantically relevant violation, and large inspection data set are difficult to analyze manually without automatic retrieval or summarize the system. And so for the goal of this project is to help solve that problems. And we want to build a conversational data analyst. The user can ask a natural language question, and the system routes to the right method. Either is predefined SQL for reliable metrics analytics, or route to RAG for inspection comment evidence, or combined SQL plus RAG workflow for both numbers and examples. And the system will use SQL analytics for more numerical analytics aggregation. RAG is for semantic search for interpreted inspection, comments, violation meanings, and find the patterns. And then we use a large language model to summarize those results into more natural language. And here is the data set and some data processing steps. So the data set, you can see in the first picture, includes some business-related information and also some violation code, even violation result, use some brief and letters. And also on the bottom, you can see we have we have a comments, which is unstructured text field. So with this data set, it requires some clean and standardizing for date, time field for extract year, month, and also removed clean handle some missing unknown violation description to improve data consistency and retrieval quality. Also, some data engineering was performed. For example, a severity level, it uses some stars indicator, 1 star, 2 star. So we need to convert them into description like high, low, medium, and also assign score from analytic use. So those are more business defined rules. Also like a risk level, it uses some brief letter codes. So we need more specific description for those fields as well. And once we process the data, have cleaned the data, and we can do real conversation workflow. And here's a high-level architecture and technology used. So the system combine using structured SQL analytics with semantic retrieval and the large language model-based summarization. And in the chart, you can see when user ask a question in natural language kind of question, and the large language model routing layers will choose whether you use SQL analytics path or RAG semantic retrieval path. So if it decide it's a SQL analytics path, then the system will send request to SQL analytics layer, and then it will return the query results such as like counting, ranking, trend, or risk score, etc. And those results then passed into a SQL summary prompt. Sometimes it will have a chart generation as well based on type of SQL question, and then pass to a SQL summary prompt. And then the large language model will generate a readable final response in a more structured output way, we predefine in the SQL summary prompt. And if from the user asks a question, it's a more related to the meaning or finding patterns, it will route it to RAG semantic retrieval path. And for context-based kind of questions, so those will route into this path. And the inspector requires first, prior to all set up, first convert it into the embedding and stored in a finds vector database. And the user question, when it comes in, will also convert it into an embedding and compare against the vector index and to retrieve most relevant inspection comments. And then depends on K, we define whether it's top 3 or top 5 based on the similarity calculated scores. And those retrieved records are then passed into RAG prompt, summarization prompt, where we define what to do, what not to do, for example, provide a summary only based on the information you have and not reinvent different new information, etc. And then those retrieved records are then passed into large language model layers to generated evidence grounded answer to summarize it. So this is the high level of the architecture. Additional, another thing it can do is once the system generates the SQL, one function is also identifying top result, then use that result as a query feed into the rec to retrieve supporting inspection comments. We'll see demonstration later. Yeah, like we discussed, we have a path for SQL analytics, and just high level, these are a few functions we predefined to do analytics, like top violation type by year by its severity, and or the trend analysis by year by severity level, or which field establishment has repeated high risk violation. Or overall serious, we are predefine some calculation to leverage different dimension of the violation to determine the seriousness of this restaurant. And then the rec retrieval and the large language model generation workflow. Earlier we have discussed how it does. So I'll skip here. And the important one, yeah, as we discussed, is the routing layers. Clear to define which path, whether the question should be go to SQL analytics workflow or rec retrieval workflow. That is useful to make sure we are routing the right path to provide appropriate analytical questions or analytical questions. Yeah. And these are a few questions we'll test in our demo. So I'm just going to go through it. First is, what are top 10 most common violation types in 2024? And what do inspection comments say about the top one? So here, this is a more, so here, the screenshot is the summary of the system output. So it says direct answer, which we predefine the structure format. The top 10 most common violation type in 2024 are related to time temperature control for safety food and proper food handling practice. So provide direct answer. And then it show the SQL results it generated based on our SQL functions. So clearly this layer routed to SQL path and to execute a SQL query and generate top 10 by violation by type and for 2024, year 2024, and also generate a chart. So we can see it's matching the direct answer, a generate time temperature control for safety food, hot and cold holding. It's around 600-ish volume. Sorry, there's a number cut off when doing screenshot. And also it's providing supporting evidence from inspection comments. This is the response to second part. What do inspection comments say about the top layer? It does say, so for community working company, this particular restaurant has inspection where hot holding temperature were not noted as a problem, and the chicken recorded at 100 Fahrenheit instead of the required 135 Fahrenheit degree. Comment indicate establishment passes inspection but failed others. And basically it lists some restaurant and what are specific violation related to these types. So obviously this one is how it does is once they generate SQL results, it select top one and retrieve the and use that as a search topic. So RAC can use that query search the inspection comment index and for records for the records that related to that issue. And the retrieved evidence gives some concrete example. So it looks like it executed well. Next one, how have food inspection violation changed across the severity level since 2016? So this one, it generates a trend chart by severity. Each different line has different severity. And then it does this high severity violation decreases from 7,000-ish from 2016 to 1,300-ish in 2026. And it does do the same explanation for low observation for low and medium severity. And he also mentioned that the limitation is SQL result doesn't provide insights into reason behind the changes in violation counts or specific factors influencing compliance, which is good because those are some guardrail we put. You don't want to put causation or reasoning if there's no direct relationship we have calculated or produced. And just a quick comparison, we want to compare this output predefined SQL, we just saw the result, versus what if we use text to SQL language model, how it does. So the bottom is text to SQL. And for the same question, the result actually shows it produced a SQL, very short SQL query, and it says a high severity violation peak in 2018. It's around the 10,000 record and have generally declined to 1836 in 2026. So we actually see contradictory result record. So predefined SQL says 7,000 here, we're saying 10K. of record. So it's overstated count. It includes more record. And the reason was that the result group equal to pass, it doesn't include, it does include the pass as well, which we don't want to because we want only the violation that failed. And also included some unknown. Although we specify those rules in the prompt, as you can see here, we specify the rules do not include result equal to pass or do not include missing or unknown violation, it still produces the result that without that in the SQL query, and consequently, it introduced the wrong conclusion. And on the right is our predefined SQL function, which provide accurate, more reliable result. And an interesting note is when we execute text to SQL, this function a few times, it does generate different results. Sometimes it can include business-related rule we define. Yeah. So the next question demo, we want to demonstrate more semantic search type of question. So find a violation similar to sanitizer or dish machine problem and provide practical corrective actions. So RAG plus large language model, we can see it produce, it retrieve the records show multiple example where high temperature dish machine or low temperature glass machine were not functioning properly, and also provide the evidence of the restaurant, what was the issues, and provide very practical actions like discontinue using low temperature dishwasher for sanitizing until it can safely sanitize at 50 ppm specific number, and also use the 3-compartment sink for sanitizing utensils. So provide some practical and technique method for correction. And on the bottom, we're gonna skip this one, and we will take a look at a pure large language model result to compare with that one. So this is on the bottom is a pure large language model one. The response gives general food safety advice such as checking sanitizer level, monitoring temperature, clean equipment, training staff, etc. The answer does sound plausible, but if you look into the details, it doesn't provide very specific, like what's the concentration sanitizer we could use, like what we saw earlier, and specific 3-compartment sink fix, etc. And yeah, so those are overall results we're seeing. Compare predefined SQL versus text to SQL. We do see some observe that they produce different results, and based on all what we observe, and sometimes it doesn't include the predefined business rules we included in the prompt. So the conclusion is that text to SQL can be flexible because you don't need to define many different SQL functions, but then it's less stable for domain-specific analytics, and also it's not able to provide reliable or repeatable results, especially for business case like a KPI, etc. We might want it to produce the same results based on the same calculation. And we talked about that. And just quick challenge and the lesson learned. So, so the challenge was choose the right method, and design prompt was challenging. Predefined SQL was more reliable for business logic, while RAG was better for comments and corrective actions. Text to SQL was flexible but less stable when domain rules were important. And however, for production, only use predefined SQL could also have a limitation scaling and managing and updating for, I would assume we would have a different SQL function for different analytics. So it's crucial to balance how to use hybrid or balance these two together to build this conversational AI analyst. And another is data quality and domain terminology. So those are required to add some extra work. The dataset included some technical codes, unclear column meaning or missing values, and also noisy comments. So some pre-processing and domain understanding is very important before building this AI pipeline, which is crucial to both needed to fit into SQL or semantic retrieval layers. Yeah, so, and lesson learned. Yeah, have based on a different way of construct the solution, the conclusion is the hybrid architecture was more reliable. We use large language model LM routing to decide the path, whether go to SQL, predefined SQL path for analytics metrics, or go to RAG for evidence-based from inspection comments, not mixed both. Otherwise, it will result in conflict answers. And the next is evaluation question. Choose the right evaluation question is important to compare which method or what method works better for better result. At the beginning, I explored more broad questions, which make the plain LM answer look acceptable as well, very similar to the using RAG we defined. So explore different questions and choose the high quality question, more maybe data set specific, domain questions that can review the value of the RAG